All right, so here when we have 10 e to the x, we're just going to use this first rule. The 10, of course, is a coefficient. It will tag along, and then our e to the x goes to e to the x. Now, that is going to be our derivative. So f prime is equal to 10 e to the x. Now, if you look at this next example, sometimes students get a little stressed out about that 15 in the denominator. Remember that this 15 is just a coefficient in the same way that 10 was a coefficient. Another way of thinking about this is that this can be written as 1 over 15 e to the x. So if you rewrite it as 1 over 15, then you really see that coefficient behavior there. So the derivative is simply going to be this 1 over 15 stays as a coefficient that tags along, and then my e to the x derivative is just e to the x. Now, of course, you can rewrite that as e to the x over 15 as you multiply straight across. Now, for this next one, we also have a coefficient of 4 that is going to tag along, and then we have our e to the negative 2x. Now, you'll notice here for this e to the negative 2x that this is not just x in the exponent. And because of that, we need to use our e to the u times u prime rule. So it's going to be a little bit more involved than just e to the x. It will become e to the negative 2x, and that is our e to the u part of the derivative rule. And then because we now have this inner function, we're going to multiply by the derivative of that inner function. So specifically, we'll multiply by the derivative of negative 2x, which is just negative 2. So again, the exponent is being treated as an inner function. Now, at that point, you will notice that you have a 4 times negative 2. Those, of course, can combine together, and that will give us that our derivative is negative 8 e to the negative 2x, and that is f prime. So again, that is our derivative. So going through a similar example here with this 11 over 2. 11 over 2 is a coefficient. It will tag along. Then for this e to the 6x, we are going to use our e to the u times u prime. And that's, again, because for this e to the 6t, we have something besides just x. It's a 6 times t. So that's going to become e to the 6t and then times the derivative of that exponent, which would just be 6. So you can then combine the 11 halves and the 6. That will become 11 halves times 6 e to the 6t. And then notice here that the 6 and the 2 cross out to just give you a 3. So that's going to give us 33 e to the 16 as our derivative. The one thing that I do want to point out is that because of the remnant of the chain rule, we usually have this times u prime, but every time you do these questions, you are going to put the e to the u at the end. So if you want to think about this as u prime e to the u, you could think about it in that regard, because e to the u does need to go at the end in general, just because usually that u prime will have something to combine with in the front of the expression. One thing I also want to mention about this is that if you were taking the derivative of e to the t, it would just be e to the t. So the reason why we're using this e to the u rule is because it's something besides just x. It's something besides just one variable raised to the power of 1.